Okay, welcome to my review for the Nikkei 4-in-1 jump starter and air compressor. First impressions as it comes out of the box, it's quite nice and chunky. It's a solid one-piece moulded case. On the front you've got a lamp and a test meter to show how fully charged the battery is, and obviously the jump leads. On the side, a cigarette lighter outlet, and on the rear you have the air compressor, the hose for which is stowed away at the side of the unit. So, that's just snapped off. First attempt at opening it. So, I think the door will still hold on, but it won't hinge out. In the door you have the provision to store the tire inflator adapters for filling up balloons, airbeds and whatnot. Those come in this nice Ziploc accessory pouch, which comes with the unit. The accessory pouch contains both mains and 12-volt charging leads, and of course the adapters. The last thing in the box is of course the 6-page instruction manual. Continuing with the robustness of the plastic door on the side, I've now fitted the adapters to their slots on the side, and another piece of plastic is shot off. If you take a look at the right hand red adapter, the plastic holding the nozzle end of it, part of that is snapped off already. It was intact until I took the thing in when it shot off and nearly hit me in the eye. Also, while we're on the back of the unit, it's a bit hard to make out, but there is actually a bulge in the unit there. You can just about make out the stress marks. It's not a straight back, it's like something's been dropped on it from the inside, if you like. But it doesn't stop it functioning. As you can see, there's a 10-minute warning on the back about using the compressor, otherwise it could explode, apparently. Anyway, without further ado, let's have a look to see how well it's made on the inside. In the back of the lid, the compressor motor with a small piston which makes up the compressor itself, the back of the pressure gauge and the switch, a thermal cutout, the back of the lamp. Moving further up, the charging circuit, which consists of a diode and a resistor, and that's it. There's no intelligent charging here. It'll just charge and charge and charge and charge until the battery doesn't want to take anymore. And of course the battery, which is made by Steyr Electric, and if you look at the website you'll see in fact the whole unit is made by Steyr Electric. The battery here being rated at 12 volts and 17 amp hours based on a 20-hour discharge rate, which is pretty standard. This is the battery taken out of the jump starter. It appears to be a standard 12 volt 17 amp hour unit, but what I did notice when taking it out, it feels a lot lighter than you'd expect one of these batteries to be. I mean, it's a lead acid battery, they're all heavy, but this doesn't feel as heavy as it should be. And in fact, if we put it on the scales, we'll see how heavy it is. 3.677 is the weight shown there. That's in kilograms. Well, 3,677 grams. If you compare that with another battery, such as this CSB, you'll see it goes off the scale. It's too heavy for the scales. These scales go up as far as 5 kilograms, and this is clearly heavier than 5 kilograms. I can do the same test with the UASA, which is another 17 amp hour battery. Again, it's gone off the scale. And I'll do a test with a 22 amp hour Lucas. And again, it's gone off the scale. Now, the average weight of a 17 amp hour battery is 6 kilograms, not 3.7. The only other batteries I've found weighing approximately the same as the stair electric one is this one, weighing 3.98, which came from one of these jump starters, which you may recognise from, once again, the stair electric website. It's another one of theirs. And this one, weighing almost the same as the one I just put on, except that is a 12 amp hour battery, not 17. Something's not right here. Proving the point with a bigger set of scales, we have here the CSB battery once again. The UASA, the 22 amp hour Lucas, and because the scales don't go down below 4 kilograms, the stair electric and the best way. Total 7.6. So the two batteries together are 1.1 kilogram heavier than the UASA and just 1.5 kilograms heavier than the CSB. To test the capacity of these batteries, I'm going to be using an ACT Meters intelligent battery tester. This costs about £150 and is used by security alarm installers, UPS installers, etc. for testing the capacity of sealed lead acid batteries, because as you'll see in a moment, just a voltmeter reading will not give you a good indication of how healthy the battery is. So first up is the STR, the stair electric battery. First of all, we have the temperature of the unit, centigrade and Fahrenheit, 12.63 volts charged to, 7 amp hours dead on. And this battery is fully charged and the whole unit is only about a fortnight old. So that's effectively a brand new battery. It's supposed to read 17 amp hours, it's reading 7. Next up we have the best way, which came from the other jump starter. All of these batteries, by the way, fully charged this afternoon. This battery is about 12 months old, 3.56. And let's do a second test.